show me. Show me. Okay, show me.
Okay, so good day everyone. I hope you all are doing just well. I think we should get started. It's 16 minutes after the actual time. Okay, so we won't be doing much today. It's just a revision on C++ pointers as well as dynamic arrays, because these two are kind of related. But just before we can actually get started, can you guys confirm if you can see my screen? Let's do it. Where is my board? It's my off turn. Um, okay, so am I audible enough, guys? I don't know if you guys can hear me. Okay, okay, Akona and okay, so if you can see my screen, if we reach a point whereby you want to add something, ask a question or something along those lines, just need to click this raise button here so that I can actually get to be notified that there is someone who wants to ask a question. So yeah, instead of you just trying to write things here in the chat, because I may not see them. But yeah, if you have something that you want to say, that, or maybe let's say you have a question that you feel like we need to cover, and given that we've already passed that point, you can just come here in the chat and then you type your question and then you send. Later on, I will see it. Hope that's clear. Okay, let me do this. Sure. Okay, I hope everyone can see my board right now. Can you? All right. Let's try to do this here. What is this thing doing? Anyway. Okay, let's actually get started. And we're gonna start with this concept of a pointer. So we wanna know what a pointer is actually before we can actually start looking at it from a coding point of view. So let's just do some quick recap. I know that you guys have done this in class, so I don't expect you guys to be that lost. So yeah, let's actually get started with the pointer. All right. So what is a pointer though? So a pointer is basically, as they've already explained to you guys, a pointer is basically a variable that stores memory addresses for other variables. So first of all, your computer represents data, or it stores. So whenever you write a C++ program and later that program data, you need to know that that data is actually going to be stored somewhere in your computer's memory, right? So that data is actually not going to be like exist only in your code blocks or an IDE. For an example, in your computer system or in the memory of a computer, you might have something like this. Let's just do this. So let's say these are just blocks of memory in your computer. And each and every of this block is called, yeah, let's just call it a location in memory. So let's say this location number 1, location number 2, location number 3, for an example. So when you declare a variable or anything that will need, that will need memory, when you say int, and then you're like, number is equal to 7, you need to know that your operating system is going to reserve 4 bytes for this integer in memory before. Okay, yeah, so let's do that. So let's say your operating system is actually going to be like, okay, let us reserve this memory here for this variable, so it can store that variable here. Later on, when you decide to declare a pointer that points to this variable, when you decide to say something like int pointer, and then you're like ptr, and you are like, and you like do this. So what you usually do here is that you are telling the operating system that the memory address or the name of a location where this variable is at must be pointed by this variable, because remember, a pointer is just a variable that stores a memory address of another variable. If that makes sense, and so this is just a logic idea behind a pointer and a variable. If you declare an integer pointer, you need to know that this pointer, it can only point to integer variables. This operator here, the ampersand, is called the address of operator, if I'm not mistaken. And this is the syntax of declaring a pointer. So when we say int and then asterisk, and we use a variable, and we write a variable after that. So this is actually called, or this is the actual syntax of declaring a pointer. And you cannot do this. You cannot store actual integers into a pointer. You can actually store the address of those variables, in other words. And so, okay, let's actually try to continue. So is there anyone who has like a question maybe? And so yeah, we can also have like double, we can actually have a pointer that points to a double, something like double pointer, and then we're like dbl underscore pointer. These can point to double variables, or this pointer can point to double variables. Oh yeah, I'm actually recording the meeting. So yeah, I think it's very, very important for you guys to understand the theory part of pointers before you can actually go into the actual coding. You'll also realize that your computer represents the name of your memory addresses in the form of hexadecimal. So I know that you guys have done the number system, right? So your computer doesn't refer to this location here as just 1 or 2, 3. So it does something like 0x and then 2, 4, 8, 1, and then maybe F here, 1, 2, 3, 4, 5, and then let's say 9. So this is the name of the location. So when you guys used to write functions, and then you're like, okay, I'm passing this thing by value. Sometimes you're like, I'm passing this thing by reference. When you used to say int, and then let me just call it my function here. And you're like integer, and then ampersand, and then you're like x here. What you were actually passing to this function was just this thing. So you were telling your program that actually I need you to go to this memory address or to this location in memory address and then try to interact with that value directly. And if you don't pass this by reference, or if you pass it by value, for an example, what actually happens is that a copy of this variable, of the value that is actually stored in this variable, is going to, oh damn. Oh, I thought you guys could see my screen. Okay, let's, um, so you guys can see my board right now. Okay, also, so everyone can actually see my board right now, right? Okay, so where were we? Okay, thank you, Mbali, for confirming. Oh yeah, so yeah, so I'm still saying that you guys are familiar with this concept of passing a variable by reference. That we need to use this operator to indicate that we actually want to interact, or we want our program to interact with this variable directly from memory. Meaning, if this function make a change to this variable, then that change is going to be persistent in your memory. Meaning, if this variable was originally let's say 7 in memory, and you pass that variable by reference here, and then this function later on decides to let's say to modify that variable into something like x plus 7, or yeah, it just adds or just increments this variable by 7. What's going to happen here is that this change will also reflect in memory, meaning later on other programs will actually see the updated value instead of the opposite, the previous old value, because you've actually made a permanent change to that value directly in memory. Whereas if it was just if you actually pass this thing by, if you passed a copy of that variable here, when you make changes to this, you're actually modifying a copy and not the original value in memory. So you make a copy, bring it to a function, and then you interact with it instead of just interacting with the original variable. And so yeah, pointers actually help us to interact with the actual variables in memory. I don't know if that makes sense, but yeah, let's okay. So before we can actually move on, is there anyone who has a question? All right. So I think now that you guys understand, the theory part, let me see. Is there anything that I'm missing out here? Let's see. Oh yeah. So yeah, I think I've explained the rest in code. It's a little bit raining here. I don't know if you guys, but I think the software does the thing. Anyway, I think now we should actually try to demonstrate this in code. So I'm going to stop this meeting. I'm going to stop this, what's this? This recording here and try to share my screen. Okay, so let's do, let's screen, enter screen. Let me just do that. Give me a second. Okay. All right. So can you guys see my screen now? All right. So so I haven't installed Notepad. I mean, code blocks as of yet. So given that the current content that we're doing here is much easier, I'll be using Notepad, and then maybe next time I will install code blocks and actually try to do that. Try to demonstrate this thing using Notepad. Yeah, for using code blocks. For those of you who just joined, if you have anything to say, you can just click this raise here. And then because now I won't be able to see your thing if you just type them in the chat. Anyway, so the first thing we need to do here is to show the syntax of declaring a pointer. Before you can, okay, I think I have someone who's trying to join.
What happens?
Okay, so Carvelo, could you please mute your microphone, please?
Oh, sorry about that.
All right, so we all know that every C++ program needs to, well, not every, but the programs that you guys are writing, so far, they need to have like a main function. So this is where the execution starts. So in other words, for a program to start running, it needs to start from like this from the main method, or main function rather. So let's start by doing the usual. It needs to return 0. You guys already know why this is the case. Okay, let's actually include our directive for for input and output stream. So let's do that. So hash include, is it called IO? Is it the IO stream? I'm not sure. We'll see if it shouts. Let's actually declare that we'll be using a standard input stream. So we'll say using, not input stream, a namespace rather. What am I saying? Standard std. Okay, so before we can actually start with anything, let's actually test to see if we don't run into any like syntax errors later. So let's just display something like okay, something like that, and end our line. And let's try to run our program. So I'll be running my code from the terminal from CMD. You guys, I know that you're experts in using the terminal, so it shouldn't be much of an issue. So that file is found in downloads and then C++. So to run my program or to compile my C++ file, I'm going to say G++ and then the name of my file. I specify the name of the executable that it must save my compilation unit into. So let's just name it something like hello, for an example. Let's see if it compiles. So now let's run the executable. Seems like it works. So now we can begin. So remember what we said, a pointer is just, so a pointer is just a variable for storing a memory address of another variable. So I told you guys that we can actually declare a pointer using this syntax. We can say int. So let's say we wanted to declare a pointer that points to an integer. We can say int asterisk, and then let's say that for an example. So this is actually a pointer that points to an integer. If, for an example, let's say we have an integer variable here, and then we do that, and then let's say something like x pointer. We said that we can use this operator, address of operator, to actually get the memory address of this variable. So what we are doing here is that we get the memory address of x, and then we store that memory address into this pointer. Notice that we cannot do this. We cannot say store x into that, because these are not the same types. This is an integer and this is a pointer. So these are not compatible types. So we need to give it the memory address like that. And let's actually try to see how these memory addresses are actually represented. And let's also try to print a value at a memory address pointed by this pointer. So let's say pointer or x pointer. So yeah, this will print the actual memory address. And let's try to print a value found at this memory address. So to do this, we need to use a dereference operator. So again, we use an asterisk followed by the name of the pointer. What does this do? So this operator, it actually tries to get a value found at the memory address stored in this pointer. So let's see if this will actually demonstrate what I'm talking about. So I'm gonna copy this because I don't want to be typing the same thing over and over again. So let's see. It is compiled, and now let's run our executable file. Notice something. See this? This is the name of the memory address where the variable x is found. So at this memory address in our computer, there is this value 9. So yeah, whenever we use the dereference operator, it actually gets the actual value from that memory address. And as you can see, this memory address is kind of, it's not really useful to us humans, because if I give you this memory address, what are you going to do with it? So this is for computers to understand. So you guys have learned the language or the way in which computers represent data, numbers. Think of binary numbers, think of your hexadecimals, think of the decimals. You guys still remember those. So those are for the computers to understand. A computer knows where this is in memory, but me and you don't. So the other thing that you need to be aware of is that if you try to write the same program in your computer, you may not get the same results for the memory address. So don't be surprised when you come across such situations. Okay, so the other thing that they've taught you guys is that you cannot do this. So we know that in C++, we can say we can do this actually. So this will declare x, y, and z as integers. But we cannot say let's say pointer for x and then y, pointer and then z. You cannot do it. So if you do this, the first variable is the one that's going to be a pointer, and the rest of them are going to be normal integers. So you guys know this by now. Okay, so The other thing that you guys need to be aware of is the type def or the alias. All right, for an example, this keyword type def, you guys know about this already. Int pointer, and then I'm just gonna call it int pointer. What are we trying to do here? So remember, we said you can also have like a pointer to a double variable. But wait, what is this keyword and what does it do? Well, so when we use when we use type def, we're actually telling the compiler that from this point, from this point going forth, when we want to declare a pointer to an integer, we do not need to be doing this anymore. We don't need to say int and then x pointer. We can just use this variable or this alias. This is not a variable, it's an alias. So we can just use this alias here to refer to int pointer. So in other words, int pointer is the same thing as int. They do the same thing. So we can declare our pointers using this keyword or this alias instead of this. And this improves readability. For an example, we can do this int pointer, and then I'm like, okay, x underscore pointer, and then I store the memory address of an x variable into that. This does the same thing. So this will do the same thing, honestly. We can do the same for the doubles, but you guys get the idea. So so is there anyone who has a question? Let's see if there is anyone who oh yeah, we can speak Mbali. But you need to start by unmuting your mic because we cannot hear you.
Hello.
Yes.
Say, we haven't done quite that, so can you please slow down and explain it again?
So you haven't done type def yet.
Yes, we're gonna do it tomorrow.
Oh, okay. So what do you like? So what do you suggest that I just continue? We just continue using this syntax of using int pointer. What's your
Sorry?
suggestion? So do you prefer us not using it in this tutorial, or we can just proceed with it?
No, can we continue with it?
Okay, no problem. Okay. So yeah, type def is basically it basically tells the compiler that another name for int pointer that we want to use is this. So as I've already explained. So let's see if we can continue because okay, so you guys already know about the dereference operator. You also know about the address of operator. So yeah, let's actually look at another point of how we can actually point, or another view of how we can actually point to to an integer. For an example, let's say we didn't want to do this. Let's say we wanted to have a pointer that points to a variable that is in memory, given that we didn't declare that variable here. So we can do this. So we can use, so wait, have you guys done the new keyword so far? see. Oh, it seems like you guys have, okay. Oh no. Okay, it's fine. You guys will actually be doing this in your class next time. Okay, so what we can do is that we can use a new keyword to actually declare an integer on the heap. So I forgot to tell you guys that the programs that we write in C++, they actually use two regions of the memory or two areas of the memory. There's something called a stack and a heap. What are these actually? Well, these are just areas or other regions of memory. A stack is basically, so for those of you who will be continuing with computer science 1B, you'll learn more about a stack. So a stack is just some sort of a representation of data, or it's this thing where you keep on popping data on top of each other. So for an example, I don't know if I can demonstrate this well here, but let me just show you guys what a stack is, for an example. Even better. But a stack is it's a data structure where you keep on putting items on top of each other. You see this? Um, so yeah, a stack is kind of a data structure where we keep on putting like data on top of each other. What then happens is that when you declare, so a stack, it's more of an automatic memory. Oh, what's going on now? The way you can see what you are writing below. I can't see your screen. Me too. What's going on here? Okay, let me just try to share it again. Share my screen again. Where is enter screen? And then let's do that. Can you guys see my screen now? Okay. Oh, so seems like time is running out. It's fine. So what we can do then is that instead of us having to declare integer variables anytime, so let's say doing the usual. So int x is equal to 9, and then later on we decide to do this. We decide to come here and we are like, instead of doing this, there is another way where we can declare a variable on the heap instead of on the stack. So we declare this variable on the heap using the new. So we can say new and then int. What does this thing actually do? This part here. So what this does is that it declares an integer variable in memory and then brings back a memory address of that to us. So instead of us having to do this, instead of us having to like declare integer variables anytime when we want to like deal with pointers, we can also declare, or you can make this program declare an integer in memory for us and then bring back a memory address to that. And so this is very, very useful for when you start dealing with arrays, as you guys will actually see. And so yeah, this pointer here it actually stores a memory address of this integer variable that we have declared on the heap or in the memory. So we can actually do this. We can do the usual from this point. Let's again try to store a value inside of this pointer. So we can use a dereference operator to actually store a value into that location in memory. So we can dereference here and do that. And this should work. And let's actually try to see if this works actually. So let's do that. So let's try to display the memory address that we have declared here, or that the program has actually declared. And let's also try to display the value found at that. So we expect to see this. But wait, there is this behavior that you guys are familiar with. Let's do this. Why do you guys think will actually be the output if we do this? If we like try to get the value at that memory address before actually initializing that value. I don't know if this makes sense. Let's find out, because I don't think it will crash. See this? You're like, wait, where is this value coming from though? Because I don't remember initializing. I don't remember giving it a value. So what is going on here? So what you need to know is that your program is not, this program that we are writing here, the C++ program, is not the only one that's using your computer's memory. So this value is probably coming from other programs, or it's coming from other. If you click Control from your keyboard, if you click Control plus Shift plus Escape, for an example, you'll come across this. So this is called a task manager. So you notice that there's a lot of what's this? A lot of programs or a lot of processes that are going on in the background in real time. So notice that I have Microsoft Edge here. So there's a lot of programs that are running. So maybe this variable is coming from another program that didn't terminate correctly, or maybe we're trying to access another program that's currently running, which is not part of what we're doing here. For an example, so don't be like, oh, so maybe my program is not running well, or when you start seeing these big numbers here, you actually need to know where they are coming from. But if we actually initialize our value, then we shouldn't come across any issue. What's going on? Oh, forgot to do that. Hey, oh, I didn't save my program. Oh, damn. So we need to declare an actual variable. So yeah, we cannot do this. Hence it's shouting. So we cannot really initialize, we cannot put an integer or store an integer into a pointer. These two are incompatible types. So we need to, what can you do then? But I guess we can just do, but this is the same thing though. Oh, damn, I forgot about something important. So when we want to store a value, or when we want to modify a value that's being pointed by a pointer, so we can use a dereference. So we can say we can dereference and then we specify that pointer, and we do this. So this will allow us actually. So now, yeah, so now we are telling the compiler that now we want to interact with the actual value found at that memory address. So this will actually work. So I forgot this dereference operator here. And let's actually see if this will work. By the way, if you remove this asterisk here, it's going to return a memory address. But if you include it, it will return a value found at that memory address. So this is how it actually works. It doesn't shout anymore. So as you can see, it returned a value found at that memory address. So these are just the basics of pointers. I don't know if you guys have any questions. But now let's discuss something important concerning memory. So first of all, the reason why we're dealing with pointers in C++, or the reason why we have pointers, is not because we're trying to be what's this? We're trying to demonstrate our programming skills or anything. So we want to be able to interact with memory. So C++ and C, so these languages are one of the languages that actually help us, with interacting with memory. And this is crucial for things like speed. So C++ is actually good for programs that require like speed, for an example. So yeah, you guys can actually go and find out like the best uses of C++. So when we declare a variable as an integer, like for example, when we say int x is equal to 9, like when you do the usual declaration, what happens is that we are declaring this variable on a stack region of the memory. So yeah, the program that we will be writing, they will either be using stack or the heap. What are these? Well, these are just two regions of memory, basically. So C++ manages this for us. So when we declare an integer like this, and then we run the program, we give our thing some data, and then we terminate that program. C++ is going to like remove this from memory when our program dies, for an example. Because remember what happened previously. We saw that other programs can actually fail to terminate correctly. See, you remember when we had like this massive number here. So when dealing with pointers, you need to, okay, I think we'll get to that point in a minute. Wait a minute. So yeah, when a program terminates, C++ is going to remove those variables or those values stored in variables from memory automatically for you. That's when that happens when dealing with a stack. But if you declare a variable on the heap, you need to actually do that for your own. C++ is not going to delete those values, because remember, as I've already indicated, we are not the only ones who are using memory. Other programs also wants to use that memory. So the memory that we use, we need to actually ensure that when we are done using it, we return it back so that other programs can use it as well. So when we do this, where is it? When dealing with pointers, those variables are declared on the heap. So we need to ensure that when we are done, we delete those values on our own. So they'll be explaining this to you guys in class later on. Yeah, so let's actually try to see how we can actually declare. We can actually not to declare to delete a variable from memory when we are done using it. So to delete a pointer, or we use the keyword delete. and then followed by the name of the pointer. Let's say, for an example, there is this pointer here. So now that we are, by the time when we reach this line here, we are already done using it. So we can just say delete and then X pointer. So this ensures that the memory address that, or the memory that we were using to store, or the thing that was being pointed by this pointer, it actually gets to be free so that other programs can use it. So this is actually a good practice to ensure that you don't have things like memory leaks. So this is just a behavior that we've seen whereby we're trying to access data that has nothing to do with our program, for example. Okay. I hope I'm still audible enough. Okay, am I still audible? What's going on here? All right. Okay, give me a second. Okay, so let's see if we can continue. Yeah, so we're still trying to work with we're still trying to work with what are these things? With the basics of pointers. So this is what you can do to deallocate memory for your thing, for your, what is it called? For your variables. So this is called allocating memory. So what's happening behind the scenes is that when you do this, your operating systems, which is Windows in this case, is going to reserve memory for this integer. You know, so from this point in time, our program will be owning, it will temporarily be owning that memory. And so when we're done, we need to give back that memory to the operating system. And so, and this is called deallocating memory. So yeah, this is called to deallocate the memory, and we use the delete keyword to do that. And this ensures that we avoid things like memory leaks and something called a dangling pointer. So I'm sure you guys are already familiar with the concept of a dangling pointer. So this is basically it's a pointer that points to a memory address that is no longer valid. For an example, if you look at this, with that port here. So if we forget, or even here, it's fine. So if you forget to deallocate the memory, what do you think will happen? So what happens is that, so what happens if you forget to deallocate the memory is that your operating system is going to assume that your program is still using that memory, and other programs are not going to be able to use that memory, as I've already said. And that can actually happen is that this pointer here, you'll find that it still points to the same memory address even after our program has terminated, and that is not actually a good practice, and that is called a dangling pointer. It's a pointer that keeps on hanging. It keeps on pointing to a memory address that we no longer use, or that is no longer useful to us, in other words. And so it's actually a good practice that you guys deallocate the memory to avoid undefined behavior. We are about to move into arrays. I don't know if there is anyone who has to actually see how arrays and pointers are connected. So I don't know, is there anyone who has like a comment or a question? All right, so what's an array though? So in this tutorial, we'll be dealing with something called a dynamic array, because you guys are familiar with this concept of a static array. So, and I think those are easy. So we're not going to spend much of our time in those. So what do we mean when we say something is dynamic? Or what is a dynamic array? Well, this is basically an array that we give a size when the program is running. So it's actually good for when like we don't know, when you don't know the size of the array beforehand. And we're going to actually see how these are connected to pointers. Now, an array is basically a data structure that stores data in a contiguous sequence. What does this actually mean? So this actually ensures that the data that we actually give to this array is going to be stored next to each other in memory. I don't know if that actually makes sense. This ensures that if the data at index number 0 is at, let's say, a memory address called 1, for an example, then this has to be, this 5 here, it has to be at 2, and this has to be at 3, and so on and so on. And notice that these are not indices, they are just the names of memory addresses. And because of that, like because arrays stores data in a contiguous sequence, it actually makes it easier for us to to do indexing. Unlike integers, where we can say int, let's say x1, and then int x2, and then int x3. When we actually initialize these variables, you realize that these variables are not going to sit next to each other in memory. So we therefore cannot say, we cannot assume that x1 is next to x2 and all of that, which is opposite for the arrays. And this is one of the features that allows us to do the indexing. Because if this was not the case, like if elements are not sitting next to each other in memory, then we wouldn't be able to do this array at 0 and then at index 1, and then just like that until the last index. So I hope this actually makes sense. So now, because of this feature of arrays sitting next to each other, what if we actually, so this, yeah, let's say we have an array of integers like this. What if we actually have like a pointer that just points to the first item in this array? Notice that if we point to these 2, then automatically we have access to everything, because we can just increment this memory address to get the entire thing, or the entire data of this array. Let's demonstrate that. Let's actually declare double pointer. I'm gonna call it array pointer. For an example. And then let's actually demonstrate this using static arrays. So let's say we have a static array here. How do we declare static arrays in C++? I think it's something like double, and then we're like array, and then we give it the size. Let's say it's of size 5, for an example. Actually, before we can continue, let's see what happens. What do you guys think will happen if we like try to display the elements of this array, because we haven't given it anything so far? Will it crash? Will it work? Like what is going to like happen? Let's see. So in C++, you need to ensure that whenever you write your C++ program, you test to actually see some unusual behavior, because this is going to be very, very important for your semester test. Because unlike other programming languages, you realize that C++ does not give us things like array out of bounds. It doesn't, and so that's the reason why it's usually referred to as an unsafe programming language. So let's see, array at index I, and then we need to end a line after displaying a single value. Oh, will it work? I don't know. So let's compile. So it worked. It compiled. Okay. So what are the values then? So what are these then? See, this is the reason why this is called. So you cannot do anything with these though, and this is not really useful to us. So yeah, you need to be aware of this undefined behavior when writing C++ programs, because it actually tries to access data from other memory addresses. As a matter of fact, if we do this, if we say actually let's try to do it here. If we say cout, and then if we try to print an element at index number 10, it's going to display something. It won't actually crash, or it won't give us an array out of bounds like other programming languages. You guys are already familiar with this behavior. So what is this? And so yeah, I think you guys are familiar with this. But anyway, yeah, so let's try to actually declare a pointer that points to the first element in an array. So the array that we have here is called, it's an array of doubles. So let's say double pointer, and then we just call it pointer like that. What's the correct way of doing this? Can we do this array at index 0? Oh yeah, actually no. So there's something that you guys need to be aware of. So there's this thing called, or there's this concept whereby an array name decays into a pointer. For an example, array name decays into. So what happens here is that we can treat an array like a pointer. So remember what happens. An array is very, very like, is a data structure that's very, very huge, for example. So when we declare an array like this, in Notepad++, I'm not actually interacting with an actual array. I am interacting with a reference to that array. In other words, the reason for that is because arrays can be huge, and we don't want to be copying arrays from memory, bring them back to our IDE or to our environment, because that can actually be inefficient, when it comes to memory. So what's actually happening is that we are interacting with a reference to to this array in memory. So this array already exists in memory, but here we're just interacting with its reference. So because of that behavior or of that feature, it then can allow us to treat arrays as pointers. So remember, I said that this is just a reference to an array. So then because a pointer stores a reference, we can just do this because these are of the same type. But you need to be aware of something. If we treat this thing as a pointer, then this doesn't point to an entire array, but it points automatically to only the first element in that array in memory. And come and think about it. Well, do you think it was going to be efficient if we had pointers that points to an entire array? What is the point of that already? Because those elements are sitting next to each other. So if we point just to the first element, then automatically we're going to have access to the entire array. Let me actually show you what I'm talking about. Let's do that. If we do this, if we just print out the name of an array without any index, what do you think will happen? Let's find out. So it compiled, run. There we go. It prints a single memory address. This memory address is the memory address of the first element in an array, this array here. As a matter of fact, let's try to demonstrate this even further. So let's say this array had elements like 67.5 and then 78.2, 90, and then how many should we have? 5. Okay, so I think this is enough. 1, 2, 3, 4, 5. Yeah, and let's actually try to dereference, because remember, I told you that we can treat this array as a pointer. And so this is just a pointer to the first element. So this pointer, it actually points to this first element here. So let's see if that's true. Okay, let's try to clear the screen first. And then I forgot to do the thing. What is it saying? Errors linked to an array from the initializer list. Why is it giving me? Oh, so I need to do this. Yeah, so I don't think we can initialize that from a different line. Yeah, it works now. As you can see, it actually prints 67. So yeah, when you specify the name of an array alone without an index, automatically C++ is going to treat that as a pointer. That this is actually a pointer to the first element in an array. If this is the case, then why cannot we do this? Or rather, okay, yes. So then we can do this then. We can declare a pointer, and then we assign array name to that pointer, because this is technically a pointer, basically, which points not to an array, but to the first element in that array. I hope this actually makes sense. Okay, so we are about to move on. I don't know if there is anyone who has like a question or so. Oh yeah, so I've told you guys about the new keyword, that when you declare a variable in, let's say, in this context or in this scope, you'll notice that, let's actually do that. So you'll notice that when this function terminates, then this variable is going to die, because this is a local variable. So it's going to be like, so it lives for as long as this function lives. So that's what I'm trying to say. So, but with the new keyword, so if we declare, let's say if we come here and we are like, not here, man. If we declare a variable on the heap, not inside of our code blocks or inside of our environment, but inside of the memory. If we declare a variable and we're like, okay, this is just, and then we store new int. Yeah. So if we do this, so what are we doing here? Well, what we're doing is that we're trying to declare a variable in memory and then return. So the new keyword is going to return a reference of that variable, and then we store that in here. We store the reference of that variable in this pointer. What's happening is that, unlike a situation where we're declaring things, the usual, where we used to say int x is equal to something, this variable is not, like, its existence is not governed by the current function. So even if this function was to terminate, this will exist, or this variable in memory, it will still exist, which is why it's a good practice for us to delete this pointer when we are done using it. Because, I mean, that memory is going to be occupied anyway if we don't delete our thing. So we're going to run in a situation whereby, other programs cannot use that memory, and we keep on coming across things like memory leaks. So yeah, it's actually a good practice to delete our thing. Okay, let's see. Let's see how we can actually go about. So it's okay. The other thing that we can do is this. So we're actually initializing that variable in memory with 3. So what we're actually doing is that we are declaring an integer variable and then give it a value 3, and then store the memory address of that variable where 3 is into this pointer. So yeah, and so that variable will exist in that memory, even if this function, or even if we were to close this notepad, that variable will still exist, unless we delete this pointer or we deallocate that memory. Because here, what we've done was to allocate memory for that variable and then put 3 there in that memory. Okay, I hope this makes sense. Okay, let's so let's actually go to where we need to go, dynamic arrays. So we are about to continue. Is there anyone who has like a question? But I think we need to demonstrate this concept of deallocating I don't think we had deallocating memory. Okay, let's start by doing that. Okay, we'll be back to these arrays. So we're just trying to like deviate a little bit. So let's try to display. Yeah, let's try to display what's this? What's stored at this value? But we already know what's there is 3. But I'm trying to I want to demonstrate the delete keyword as well. So let's try to display the memory address of this. And let's also try to display the actual value, which is going to be 3. And then we need to deallocate memory afterwards. Deallocate. And then here we are just trying to allocate memory for this integer variable. To deallocate memory, so let's, yeah, so once again, to allocate, we need to use the new keyword. And then to deallocate, we can just say delete like that. And then we delete the actual pointer x, and then pointer. And let's actually try to see the actual output after deallocating that memory, after deleting that pointer. Let's see what's at that memory and what is the actual value there after deallocating. So that's what we're interested in. Let's see the actual value as well. Let's also try to like jump a line, or let's just jump a line. Actually, let's just do that after deallocating. Yeah, what are we trying to do here? So we're trying to see the values that are found in the pointer before and after deallocating that memory, because we said that we need to delete the pointer. So what happens if we delete the pointer and then later on we try to access the values at that pointer? So that's what we're trying to do here. Okay, so it compiles. Now let's run the executable. Okay. So let's see. So we had a 3 as expected, this 3 here. And then it was stored at this memory address. Now we deallocate that memory. Look at what happens then. So it seems like our pointer is still pointing to the same or to a similar memory address, because if you look, I think it's the same memory address, because this number here is the same as this one. But this is not enough though. We want to ensure that, okay, but at least that value is gone. So at least that memory is free. So we have freed the resources, or we have returned, the resources back to the operating system. But still, man, we want to make sure that this pointer does not point to anything, because now this is what we mean by a dangling pointer. It's a situation whereby a pointer points to, to a memory address that is no longer useful to us. So this is called a dangling pointer. So it's just hanging there without pointing. So because that memory address is not useful, so it's called a dangling pointer. So we want to ensure that after deallocating that memory, this pointer doesn't point to anything. So in that case, then we'll then need to come here and say, not only do we want to delete a pointer, but we want to set this pointer. Actually, it's an X pointer, so X pointer. We want to set it to null. Null pointer, yeah. So null simply means nothing. It doesn't mean 0, it means nothing. So we are saying this pointer must point. So after deleting that pointer, after deallocating that memory, this pointer, it needs not to point to any memory address, but it needs to point to nothing. So that's what we're trying to achieve here. And let's see if this will behave as expected. As you can see, it doesn't return anything as far as the memory address is concerned. And yeah, finally terminates. Oh, okay. So does this concept of a dangling pointer make sense though? Let's see. Any. Okay. Okay. Now, next up. So now we need to look at dynamic arrays. So remember what we said dynamic arrays are. So dynamic arrays are just, instead of us having to do this every time, or instead of relying on static arrays, because now here we know the size beforehand, hence we gave it 5 here. So the size of this is 5, so we know this before giving it the actual values. So what if we wanted to have like a kind of a situation whereby we don't know the size of the array before actually storing these values in here? That's where a dynamic array comes in. So dynamic simply means, it happens while running. So we're giving it a size when the program at runtime. So we give it a size here when the program is running. For static arrays, we give it the size at compile time. So the moment you click compile on your code blocks, then the compiler is going to decide the size, before you can actually start interacting with okay, give me a second. Give me a second. Okay, let's continue. Sorry about that. I had some distractions here. Okay, now where were we? Okay, I can't remember where we were, but I think we're trying to discuss this concept of dynamic arrays. So up to this point, we've already indicated that an array can act as a pointer, or an array name, not an array, but an array name can act as a pointer, which points to the first element into that array. So let's actually see how we can actually do this with dynamic arrays. Let's see how we can actually declare dynamic arrays in that sense. Now, let's try to declare just a dynamic array of doubles. So we can actually do this. So we can say double, and then we're like, let me just call it an array like that. And then mu double, and then I give it the actual size. So let's declare our size here, and then for example, what are we doing here? So this part here, what it does is that it constructs an array hey, what is this thing doing? It keeps on this thing. So what's actually happening is that this platform keeps on, so it keeps on stopping sharing my screen. So I don't know why it's doing that. So yeah, you guys must actually tell me the moment you see that you can't see my screen anymore, because it doesn't actually give me a warning that my screen is now invisible. Anyway, so this is it. So I hope you guys can now see my screen. Toggle is typing. Okay. Does yeah. So is my screen visible now? I think it should be. Yeah. So you guys must tell me the moment it stops being visible. So yeah, this is what's actually happening. Sure. So this is basically us saying double pointer so this is us this is us doing this. Why is this thing not commenting out? It needs to be on the other side. So yeah, double pointer and this are the same as I've already explained before. So this syntax of using an alias. So this is called an alias, by the way. So you guys already know about this, that this is an alias. What's the spelling? Something like that. So yeah, what we're trying to do here is that the new keyword, basically, or this part, the one that starts with the new, it creates an array in memory. That's what it does. So it creates a memory in address, and then it gives us a reference to that array, basically. Once again, let's try to find out what's going to be like the data of this array before like giving it any values. First of all, let's try to print our pointer, this array here. So this is just a pointer, and it's an array. So remember, an array acts as an array name acts as a pointer with the first element into that array that we've created. And this array is actually found in memory. So what we have here is basically a pointer that points to the first element of that newly created array. So we've been demonstrating this for a long now. So let's see. Oh, I think the problem is this thing here. Let's do that. So it says what? It says it must have a integral or enumeration type. Double point array. Why is it giving me this error? Is there anyone who has an idea? Oh, damn. So I think this is the problem. Yeah, so you see what's happening here. This is a memory address of the first element into this array that is newly created in memory. So now that we have access to that memory address, let's actually try to do this. So remember, this is actually a pointer. This is not an array, it's a pointer. It's a pointer to the first element into that array. And this part here, it actually creates an array. And instead of returning the entire array to this keyword, it returns only a reference to the first element of that array. So you need to understand that. It's very, very important. Otherwise, you wouldn't be able to like to debug efficiently. So let's see what's the value though. So it gives us this. So that's unfortunately that's C++ for you. It randomly allocates data, or rather gives data to your array until you give the data to the array on your own manually. So let's see if we can actually try to populate our array with some data. So to begin with, the reason why we have this is because of our it's because of the dynamic feature. So we need to determine the size at runtime. So it must not be hard-coded. So we can do that. We can say this is our size, and then we prompt the user to give us the size at runtime. So we can say something like that. And then we do that. Less than. So this needs to be less than the size. And then, so yeah, in C++, we use a zero-based indexing. So the last index is going to be 4. If the user gives us 5 as the size, then the last index is going to be 4. So you guys are familiar with this context or this concept. So now we have the size. What should we do next? But wait, we cannot really determine the size after allocating. We're gonna get an error. So we need to get the size first and then allocate memory. So let us try to adjust. So after getting the size, we allocate memory. So yeah, so this is what it does. Your operating system, Windows, is going to reserve memory for your array before you can actually start using your array. So which is why you need to delete that thing, that memory when you're done. So let's actually see how we can actually go about this. Now that our array has a size and we know where to look from and where to, let's actually go and try to see if we can populate our thing. How can we do this? Can we say, do you think, I don't know, do you guys think it's possible to do this? Let's say enter value, and then you concatenate, and then like that. Do you guys think this is possible? And then we just read this into that. I guess we'll never know until we try. So let's actually see if it's possible. I don't know. I've never tried doing it this way. Okay. Okay, let me just. So we're gonna say G++ and then the name of our file. And then our executable file needs to be that. So we have an error, it says this was not declared in the scope. So this part here, I guess. Where else did we use this? Yeah, I think now it's fine. So do you guys think this will work? Like according to how you guys have been writing your C++ programs during your practicals? Because I have never tried this before. Okay, seems like it worked, but let's see if this will. But how would we know if it works if we don't really display? So we need to display, but let's see if it crashes first. 23. Oh, we didn't actually read the size. So we need to come here and say C in, yeah, C in into the size. So we need to, whatever we get from the user is the size. We need to read that into this variable. Then do this. Now let's try to display something like just to see if it worked. So index number 2, for an example. Or we can display the first element. So we can just say, let's use our pointer. Now when we use it this way, it acts as a pointer. But when we use square brackets, it will now act as an array. So so this is what I've been trying to emphasize. So this pointer points to the first element. So let's just try to display the first element. And because this is a pointer, we need to use a dereference operator to get the actual value. Or so you cannot do this. I don't think you can, because already this is a value. So you cannot dereference a value. We need to dereference a pointer. So we'll try to see if this will actually work. So let's terminate this, and then let's try to compile. So we have an error. So it says we miss a semicolon. I think it's here. Okay, so it gives us an error. It says what? Input file test is the same as the output file. Oh, damn. There's a typo. So this executable needs to be something different. So the size is 3, for example. Value, that, and that. So notice that it has displayed 23 here as the output. So it actually worked. So, and 23 was the first item in our thing. And as I've already indicated this. So I was not sure if this would actually work or if C++ will actually allow us to do this. Another way of storing data or of reading the data into your array is to do this. Can we say array at, I'm not sure if this will work once again. How do you guys go about this? I don't know. Okay, so but for this problem, let me just try to like take I and then multiply it with some value and then add 10 to it, for an example. So this is how we can actually test to see if our array is able to receive the data in that sense. So let's see. Let's try to display. So in this case, then our first element is going to be 10, because when we start, we were trying to display this, and we said that this is the pointer pointing to the first element into our array. So the first element that we're trying to store here is going to be 0 times 4, which is 0, then plus 10. So we can expect that this will bring back a 10. So this is how you can actually go about testing your programs as you proceed. Okay, let's try to compile. and then our executable, and then the size is to be 2 and then 32. So what does it say? It says oh, actually, I think we didn't do the thing. Okay, it's fine. Let's try that again and see what's going on. Test.c++. And then our output is to be that. And then we run the program. It says size, I give it. Oh yeah. So it didn't really expect a thing from us. So then we don't need this then, because we're not really getting an input from the user. This line is not really necessary. I forgot to get rid of it. So as you can see, our thing is 10. So once again, this is an indication to show that this is actually a pointer to the first element into that newly created array. Yeah, so that's what I'm trying to demonstrate here. But if you try to do this, if you remove the dereference operator, what do you think will be the output? A memory address of this value, here. But there's something that I need to show you guys before proceeding to the next sections. So notice that an integer in memory takes 4 bytes. You guys know this already, that an integer takes 4 bytes. So because I've told you guys that an array stores data in a contiguous sequence, meaning values are stored next to each other in memory. So how are these memory addresses going to be related? Like, how can we move from the first address to the other? Like, what's the relationship between the two? Can we kind of try to find an incremental value between them? So that's what I'm trying to show you here. So how can I demonstrate this? Oh yeah, so let's actually try to store values into our array and then try to display their memory addresses to examine how they are actually related. So let's do that. We need to compile this first because we don't want to be having these things here. As a matter of fact, we need to display the memory addresses as well. So let's do that. So for int, I don't know. Are you guys aware? Okay, never mind. I wanted to use a different syntax, but I don't think it's necessary here. So yeah, let's do that, and then I should increment. Now, so what do you think the relationship between the memory addresses is going to be? So for an example, if I print this, so we know that if I print this, okay, let me just do that. So we know that if I print this, this will bring back a memory address, a single memory address to the first element. So then I can just increment and do this then, and not actually do that. So yeah, what do you think will happen if I like decrement here? So that every time when we go to the next iteration, it increments by 1, by 2, by just like that. What do you think will happen? Let's see. Test output needs to be that. And then the size is 4. So this is what I'm talking about. I don't know why it's just doing load. Okay, so it seems like this time around, it didn't really, let's see, 98, it didn't really like it will bring these values in a way that we can actually demonstrate them. Let's try this again, because there is something that I want to show you, which I think is not coming up here. Let's see. Maybe this time around, the memory addresses will be different. Okay, let's try a 3. Same. Okay, it's fine. So what I want to demonstrate to you guys is that an integer in memory. Wait, this is not an integer, it's a double. Oh, hence it's doing this thing to me. But it's still an integer though. Okay, never mind. Let's just do it here. So an integer takes 4 bytes in memory. So you guys already know about this. But what does that mean from this context? So did I copy that? I didn't. Damn. So you'll notice that to move from this memory address, we had to increment here by I. I'm sure you guys can see this. Okay, let's see. Can I copy this and put it here? Okay. So what I wanted to demonstrate to you guys was that since an integer takes 4 bytes, so I'm going to modify these addresses here, because right now, because the computer or the operating system randomly allocates memory, it won't really allow me to like choose for myself where exactly do I want to store those. So when you run your program, or when you do this on your computer, you will realize that it gives you something like this. So let's say here it was around 90. Let's actually give it something like, yeah, let's give it something like, so it's 90 and then 94. So here it goes to 90. So something like that. Wait, what is 4 plus 94 plus 4? That's 100 and my math is bad. Okay. So the point that I'm trying to make is that let's do that and then 16. Since an integer takes 4 bytes, you'll notice that the difference between these memory addresses is 4. It goes from 90 to 94, from 94 to 12, to 112, and then just like that. So I hope you guys get the idea. So this is one of the features that we can actually use to debug our programs. Yeah, so I hope that actually made sense. But remember, I told you that we need to actually, it's a good practice that when we are done dealing with our pointers, we need to deallocate that memory. So this array here, the moment we terminate our thing, it still points to the same memory address. So we need to ensure that it doesn't do that. So let us try to delete this pointer. So we're going to say delete. Now, because this pointer, or because we're dealing with an array, we need to use square brackets and then specify the name of our array, and we can make it point to null. So if you want, you can use this null pointer like this. So these two do the same thing. So you can choose whichever one you prefer. So yeah, this is what we've done here. We are trying to deallocate the memory that we've allocated here for this array. And this ensures that our pointer does not point to anything, or it doesn't point to a memory address after deallocating that memory. Yeah, but wait, isn't this thing going to crash here? Let's see, G++ and then test. And then our output needs to be that executable. Oh yeah, it doesn't crash. I guess it works. Yeah. So yeah, if you try to yeah, so if you try to display the, seems like we have anything in the chat. Oh, nothing. So if you try to display like your pointer, this pointer, after deallocating, you already know what will happen. We won't really get anything. So that's the point of trying to delete. Or trying to delete a pointer and then make it point to null. Anyway, I don't think there is. So is there any question though? Because I think we need to move into 2D arrays. Have you guys done 2D arrays yet? See, where's my okay, so it's fine. Oh, the other thing that you guys need to know here is that we can also use the same syntax to actually display our things, our values. So let's actually try to copy this, and then just put a dereference operator here, and try to see if it will display the correct values or outputs. So let's do that, and then we just need to put a dereference operator, and then see what will be the output. Yeah, you can do this as well. So you can always play around with these pointers, or with the syntax of pointers. You can always try new things to see what happens when you do what. So the size is 3, and then, so as you can see, it actually displayed those values that we have populated our array with in this loop. So yeah, we dereference to get, so yeah, 10 is a value stored at this memory address. And then 14 is actually stored. I think we have displayed something extra. Yeah, of course we have. So this, you see this line here? We don't need this here. So this actually speaks about the, oh yeah, sure, nothing, no problem with that. And then at 90, not at 90, at this memory address, we have, I think it's 18, yeah, 18. So when we dereference these memory addresses, we get what's actually stored at those memory addresses, the actual values at those memory addresses. So let's actually go into the 2D arrays. Okay, let me just go back here and try to see if I can. So I just want to display the 2D arrays here on the board. So I'm going to stop sharing the screen for now and actually share the board. So I hope you guys can see my board. Okay, yeah, so the last thing that we'll be going through in this tutorial is this concept of a 2D array. Let's see. So a 2D array is basically, you guys already, I'm just making you guys revise. So a 2D array is basically something like a table. You guys know what a table is, I know. And then, so in this context of C++, the first thing we're trying to do is to like, okay, so we're trying to declare, or trying to like create a single 1D array, which looks like that. It's just a 1D array, which looks like that. And then every element in this array is just a pointer to integers. So these dots here represent pointers. So like that. This is how we actually allocate memory for 2D arrays. We start by declaring, or start by creating a 1D array or a single array of pointers to integers, for an example. And then, so this pointer points to a row that we'll actually try to create here. For an example, when we are done doing this, we're then going to extend this. We're going to extend every row and give it multiple columns. So that's what we're trying to do. So this is the basic idea behind a 2D array. We start by creating a 1D array of pointers. So these pointers can actually point to, to this integer that we'll be trying to store in these cells or in these spaces. And then we extend and make it have multiple columns, for example. For semester test 2, this is what you guys will be doing. So you will be moving a player. So let's say there is a character here. So this character will be moving from here, then it will be going through, and then there are some obstacles, and then like that. So it will be trying to move until it reaches the last column or the last row, for an example. When it does that, the player is won. But if it comes into some sort of an unrestricted area, the player may lose, and the player may not move out of bounds. So what happens if this guy tries to like move out of these bounds here? So those are the things that we'll be just trying to handle. So for semester test 2, this is what we'll be going through. So let's try to see how we can actually do this in code. Like, how can we go about trying to like create a single 1D array like this, and then later on try to extend and make it have multiple columns? And yeah, let's try to do that. So let me try to share my screen again. Like that. I think this was long enough, but anyway. I'm just going to get rid of these things here. Okay, so let's see. So you guys are now familiar with this concept of, so when dealing with the 1D array, we can just use the what's this? An int pointer. So a single integer can just indicate to you that, oh, now we're dealing with an array. So still remember when we used to say that, what's this? When dealing with, let's just do this just to remind you. So int pointer, we said int pointer, and then we can just say this is our array, or we can call it our pointer, for example. So notice that this was new int, and then also previously we used double, so we can do this as well. So notice that this was just a 1D array, and for that we used just an int pointer because this is an int pointer here. So it can be a little bit different with a 2D array. Let's see how we can actually go about that. So yeah, let's try to demonstrate this with a 2D array of integers. So let's see if I still remember very well, because I don't think I still do remember. So as you might have guessed, we can use double asterisks for a 2D array. So if I include one asterisk here, this will mean that, I'm putting an asterisk on top of the already single one that I have here. So this is basically a double asterisk. So you guys are into this thing of saying 2D array and then we can just say new and then int. By the way, let's try to do this because it's going to be, but anyway, we'll do that later. Yeah, I think we have to do this. So let's try to declare like the number of rows and the number of columns. Let's say we had like 10 columns and 10 rows. So calls to be that. Now, remember what I told you that we need to start by creating a single 1D array of pointers. So this thing here is basically trying to create a 1D array of pointers. But notice that those pointers were kind of in a row, if you can still remember. Oh, I can't access my thing anymore, but it's fine. So then we need to give it the number of rows here, like that. Will this work though? I don't know. Then we need to go through each and every row and extend each and every row to make it have multiple columns, as I've already indicated. So let's see if this will do what we want. And then, yeah. So we're going to say our 2D array. Okay, let me just do this deliberately. Our 2D array is going to be that, and then new. So yeah, now we're giving it we're actually extending that into an array of integers. Because here, this was just an array of pointers. It points to integers, and those integers are just those extra columns, basically. So we've done that for each and every row, because at this point in time, every row contained those pointers. So this is actually, how can we do this? So we need, we need this here. Now let's actually have another loop. So you guys are familiar with this concept of nested loops. So let's actually try to nest another loop in here. And then for this will be running through the columns. And then like that. So what I'm trying to do here. So notice that at this point in time, we have done what we needed to do. So our array is now allocated memory for. We have this 2D array, which obviously has random values. We know that C++ always allocates, or it always gives random data to our 2D array or to our arrays. So we know what to expect. So let's try to put our own values into this 2D array. So obviously we're going to say yes. See now. Okay, so we're going to have a 2D array and we specify the row and the column. And then what do we put though? So just for simplicity, and this is what you guys will be doing in your game development in this module. You'll be initializing each and every space in this 2D array with an empty space, basically, and an empty, so that can just be 0, for example. So this is an empty space. It can just be 0. So what we need to do here is just put an empty space in each and every cell of our 2D array. Yeah, so now let's try to display and see how our 2D array will actually look like. So I'm going to just save time. I'm going to duplicate this and then just try to. We're not allocating memory here. What we're doing here is basically to display. So C out and then our 2D array, go to a specific row and a specific column, display that value, and then just leave space when you're done. And then it shouldn't end a line. It will only end a line when it's done displaying a single row. So by the time when the inner loop is done, it means that an entire row is done. So then can we end a line? So when done with a single row, we can end a line. But this is not gonna work though. Especially here, we might get some errors. Let me actually show you these famous errors that you'll actually come across. Okay. So let's try to compile. Okay, tell the CPP, and then I'm putting this into. You see what's going on here. So it says you cannot convert that into that. So we need to start here. So this needs to go through each and every row. Remember? So remember that at this point in time here, where here, we have like this 1D array of pointers. So we need to go through each and every row and access every pointer and then try to like extend and make it have multiple columns. But will this work though? Let's see what errors we have then after this one. But I think I'm missing something. C++ and then test.c++ and then okay, so it says what? So it says row was not declared, not declared, not declared. Oh, not here, but here. Yeah, not declared, not declared. Okay, it's fine. So this is supposed to be, where is it? Here, we need to use R. These are our indexes because the variables here are just R and C. So this is what we need to use.
Tendo,
Yes.
please check row number 090. Yeah,
Check what?
it's fine now.
Oh, okay. So yeah, so this is the reason why we're getting an error. Let's see if we still do get an error. Okay, I'm gonna clear that and then let's try to run. So yeah, you don't need to be worried about like trying to run your code on your terminal. You guys use code blocks. But yeah. Let's it seems like it worked. Let's see. So this is what your 2D array will actually look like. So in this method test 2, you will actually need to randomize a column and a row. So that every time when you click run, the player will sit, let's say, somewhere here. Actually, let's try to hard code this and actually show you guys how you will be expected to do this. So our 2D array here is okay. Let's go to row number 4 and row number 0, and let's actually put a player. So we can come here and declare player and be like a player can just be. So it can just be something like, let's say 2. That's our player. And then you can have something like an obstacle. And then our obstacle can just be something like a 9. And then we need to, yeah, let's just do that. So let's put a single player and 2 obstacles. So in another cell, we're gonna have that obstacle, and then in another cell, we're gonna have another obstacle. So yeah, let's try to see if this will display an obstacle, not a player. Obstacle and an obstacle. Yeah, so for example test 2, this is what you guys will be doing, but yeah, by the time you get there, you will equip yourself with what you need. So as you can see, here's our player, and here's our obstacle. So meaning, if our player moves and reaches this point here maybe, and then they try to move to this position, they shouldn't be allowed to do that. And maybe if this was a dangerous zone, so let's say a player, when it comes to this region here, then the player will just do something like to explode, then the player loses. So your game will display something like game over, you lost. Or if the player moves from here up to this, it will win, and given that there are some obstacles that are just populated here. But obviously, every time you click run, these things are randomized. So next time it may be somewhere here, and this will be somewhere here. So you guys get the idea behind a 2D array. So we'll actually try to go into detail, into like the actual details of this next time, because now I think we are out of time. But before concluding, is there anyone who has like a question? Yeah, anyone who has a question? Because otherwise, I think this can be the end of our tutorial. So yeah, this was just the basics, or the basic introduction into pointers, as well as what's this, dynamic arrays, to actually see how pointers are connected to dynamic arrays, and arrays actually, how do they relate to pointers. So we have shown that a pointer, an array rather, can be treated as an array. And technically, we say that an array name decays into a pointer. And so an array name can actually act as a pointer that points to the first element into an array. So we've also shown that this is the syntax for declaring a 2D array, that we need to start by allocating memory for a single 1D array, and then try to extend that by making multiple columns. And then here we're just trying to initialize, so we're trying to initialize the cells, because C++ is going to give us that garbage, we know, those random values. And then we also try to do to place items into a 2D array. So that's in a nutshell what we have done in this tutorial. If there is no question, I guess you guys will have a great evening. And yeah, yes.
And then what about deallocating?
Oh, thank you for that. Thank you, and I really forgot. So yeah, there is a 2D array, so we need to deallocate memory for the 2D array as well. So it's a little bit different. So remember, with an array, or rather with a pointer, we said we can do this. We can just say dead and then pointer name, then we're done. And then we allocate this pointer to null. And then for arrays, we said we need to include the square brackets. Yes. And then this one we're dealing with an either 1D array though. But what about a 2D array? So for a 2D array, it's a reverse of what we're trying to do here. So remember what we're trying to do here. We're trying to, at this point, we're trying to allocate memory for every row. So we need to go to each and every row and deallocate memory. So that's the reverse. So we need a loop, therefore, to go through the number of rows and deallocate memory first. And then, so we just need to say delete. So we can specify our 2D array here and say 2D array, and then R. Yeah, so I hope this works. So when we're done with this, now we have that single 1D array. Do you still remember it? So we have that. So we can just come here and say, okay, delete a 2D, that 2D array. And then make it point to null. Or can we do this instead? Let's see. Do we necessarily need to come here and do this? But yeah, this is the basic idea behind that. But let's see if this will work. But I don't think it will actually show us if it works because we're not really trying to output anything here. G++ and then paste. But yeah, this is the basic idea behind deallocating memory from a 2D array. We need to start by, so we need to start by like deallocating this from this point, 1D array of pointers. Deallocate from here to this point for every row, from here to this point, just like that for every row. Then what will remain is just a pointer that points to this. Then we can just delete that pointer. But let's see. It won't show us anything. So yeah, but next time, I guess our tutorial is going to start with 2D arrays. So we'll actually go into detail into how can we actually go about doing all of these operations from a 2D array. So yeah, anything more than this? Is there anyone who has a question? See. Okay, so yeah, I think we'll conclude it here. And then yeah, I'll actually update you guys on when will we actually have our next session. And yeah, thank you guys for attending. You have a great night. Yours.